Hi, I'm David Adam, a student and undergraduate research assistant here at UW-Madison. I'm here today to tell you about what's happening at one of the Energy Frontier Research Centers administered by the Department of Energy's Office of Science. 3 national laboratories and 4 universities have teamed up to investigate how heat moves through a nuclear fuel that's been damaged by radiation. The investigation of how heat moves through nuclear fuel seems like a pretty daunting subject to understand, but you probably know more about it than you think you do. Do you recognize this? This is a cell phone, and cell phones and heat share one major thing in common: waves.
Cell phones use waves to communicate with the cell tower, which then passes on the waves to its destination. But what if something gets in the way of the waves being transmitted? That something could be a brick wall, and it interferes with the waves so they are unable to reach their destination. The result? A dropped call.
If I wanted to make sure I never had a drop call, I would have my own cell phone tower and I would not make a call more than 5 feet away from it. But that's absurd. I could and I never would do that. This scenario is very similar to what's happening at the EFRC. That is, the perfect scenario does not occur in the real world.
The perfect scenario in a nuclear fuel is where all of the atoms of a solid line up perfectly in a lattice. As heat passes through them, the atoms vibrate like a wave and then return to their original position.
Unfortunately for us, there's no such thing as a perfect lattice. All materials have what are called defects, and in nuclear fuels, defects occur naturally, simply because of the way nuclear fission occurs.
Nuclear fission occurs when a particle called a neutron strikes an atom like uranium. When the neutron strikes the atom, it splits it into 2 different atoms and releases an enormous amount of energy. 3 other neutrons are then released, and those 3 neutrons continue the chain reaction and strike other uranium atoms. When seen from a simpler perspective, the lattice of the uranium fuel is disrupted and changed. Like the brick wall blocking cell phone waves, the defects created by fission changes the way that the heat moves through the lattice. This is exactly what the researchers at the EFRC are trying to predict: how heat moves through fuel that has been changed due to nuclear fission.
Breakthroughs have been made, but they haven't been made by themselves. A lot of hard-working, dedicated people have put many hours into these investigations.
These people include Dieter Wolf from Argonne National Laboratory, David Hurley and Jian Gan from Idaho National Laboratory, Ben Larson and Judy Pong from Oak Ridge National Laboratory, John Moore from the Colorado School of Mines, Antar El Azab from Florida State University, Michelle Manuel and Simon Philpott from the University of Florida, and Todd Allen from both University of Wisconsin-Madison and Idaho National Laboratory. Hopefully we've provided you with a painless explanation of the work being done at one of the Energy Frontier Research Centers. Thanks for your time, and check out our website for more information.